Hello and welcome to a new video. This video is going to be on graphing lines using slope-intercept form, which is pretty fun. So last lesson, if you were with me, we graphed in general. We graphed things that weren't just lines, but we did graph a line. We used a table of values to do it. So today we're going to go back to what can we do with linear equations for lesson 4 here, graphing using slope-intercept form. Now, if you would like to download a notes page so that you have something to write on and don't have to make all these coordinate planes yourself, head to the description and click the link, or there should be a thing that pops up above my head. You can get a free notes page and follow along. Without any further ado, let's get started. Okay, let me remind you about what linear equations are. Linear equations have at least one variable, and all the variables are to the first power. So if we have a squared, we're not talking about linear. Cubed, not talking about linear. Also, if we're just doing something to x or y that really, if we're just doing anything other than multiplying or adding a number, then it's not linear. So absolute value of x is not linear, and square root of x is not linear. So we really are wanting to look at the simplest case we can for graphing here to start off, and then we'll build on that later on. And later on in Algebra 1, we'll learn about how to graph some other things, and then we'll expand that in Algebra 2 and pre-calculus, but we're starting off real easy right now. So if we remember what we said about a line a couple lessons ago, there's kind of two ways that we could talk about a line so that we know we're talking about the same unique line. One would be for us to pick out 2 points to use. So if you're looking at a line, if you can pick out 2 points that line goes through and tell me those points, then I can draw the same line. But the other is if we pick out a point and the slope. So if you say, okay, it goes through 2, 3, and then the slope, which is rise over run, is, up 1 over 2, or something like that, then we can draw the same line just based on that information. So instead of using a table of values, which was fine last time, what if there was an easier way? Because with the table of values, we were finding 5 points, and we don't need to find that many points for lines, right? We could just find 2 points. So that's actually one way of going about a table of values that would be easier than what we did, just picking 2 points to plug in instead of plugging in 5. But also, if we just know 1 point in the slope, then we can draw a line that way. So let's explore that idea in what is called slope-intercept form. So slope-intercept form is a special way that we write an equation that has an x and a y, a linear equation that has an x and a y. And so it's in slope-intercept form when it's solved for y, or when it looks like this, y equals mx plus b. Now, in an actual problem, the m and the b would both be numbers, but the y and the x would be y and x. Remember that our coordinate plane has an x-axis and a y-axis. Remember that our points are x, y. So we're going to see x and y in our problems a lot. And what's happening when we write it this way, y equals mx plus b, is we're saying, okay, here's the relationship between x and y. When you plug in something for x, you multiply it by the m, and then you add whatever b is. And so in this case, it's really cool that it works out this way. M is our slope, and b is the y-intercept. Now, I'm not sure that we've talked about what a y-intercept is. It's where the graph goes through the y-axis. We could have a y-intercept, so that's where it goes through the y-axis. We'd have an x-intercept, which is where it goes through the x-axis. And so it just so happens that when we're in slope-intercept form, when we have our graph solved for y, our equation, when we have our equation solved for y, that these two numbers appear and are really obvious. M, which is slope, so m, which is rise over run, and b, which is our y-intercept, which our y-intercept is a point. So it ends up that if our equation is solved for y, we have a super duper easy way to graph as long as we know, these two things. So typically if you were to walk up to somebody on the street and say, hey, do you remember anything from algebra? I would say y equals mx plus b would probably be one of the things that they could spout off, because we usually drill it in quite a lot, that this is what slope-intercept form is. Graphing a line is one of the major points that we do in Algebra 1. So keep that in mind if you're like, I'm not going to worry about this. No, this is kind of a big deal. We want to learn how to graph with slope-intercept form. Example 1. Graph the following equation. We've got a nice coordinate plane here. we've got this equation, y equals 1/2 x minus 3. So the first thing that we need to make sure we understand is what this equation is telling us. This is solved for y, and all of ours today are going to be solved for y. So that means that this is in y equals mx plus b. And we can figure out then what is m and what is b. M is the number that's in front of x, so m is 1/2. B is the number that's being added or subtracted, and since it's minus 3, we would say that b is negative 3. So two things here. B is what we're going to begin with. Okay, we're going to start by putting a dot on the y-intercept. So at negative 3 on the y-axis, which is the up and down vertical axis, I'm going to put a dot here at negative 3. Then I'm going to look back at the slope and say, okay, where should I put my next point? And there's two ways actually that we could go, right? Because my line's going to go to the right and it's going to go to the left. So for 1/2, we've got rise over run for slope. So that means that as we rise 1, we want to run 2. And those are both positive, right? It's a positive 1/2. So that means I want to go up and right because both of those are positive directions. So up 1 and right 2 puts a point here. Now, that's all I technically have to do as far as points go, but I've learned over the years that my, my lines look significantly better if I make lots of points than if I just make 2 and then try to draw a line. This is also where we could use a ruler to help us. I'm not really into that, but you could use a ruler. What about if we wanted to go left, though? If I wanted to go down 1, what direction would I run? This has to do with the way negatives interact. If I go down 1, I'd have to go left 2 so that my negatives would cancel and I'd still have a positive. It's kind of a weird thing that we've got going on. This can be one of the things that trips people up. I'm going to go down 1 and left 2. Or we could just continue the pattern backwards without even really thinking about. So here's my line, y equals 1/2 x minus 3. Let's look at the next one. Example 2. So we're in y equals mx plus b. We can pick out what m is. M is what's in front of x, so m is 4. And b is the number being added or subtracted, so b is 1. So right away we can begin by putting a dot at positive 1 on the y-axis. Then we'll look at our slope. Now our slope is rise over run, which is a fraction, but our slope right now, 4, is not a fraction. How do we turn a whole number into a fraction? We put it over 1. And we put it over positive 1, because if we put it over negative 1, that would change this to a negative 4. So we put it over a positive 1. That means our rise is 4 and our run is 1, both positive. One of the ways I sometimes will write it to kind of help visualize is putting an up arrow 4 and a right arrow 1. I'm going up 4 for every time I go right 1. So 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And we could go backwards as well. And it probably is going to be even trickier to draw straight lines that are like really close to being up and down. That's my experience, but just do the best you can. This looks better, I guess, than if I had done this with my normal writing tablet. I don't know. All right, now we're just going to keep graphing, and each of these next ones I think kind of has a little bit different of a thing going on for us to explore. By all means, if at some point you feel like you are ready to try to do this on your own, that's a great idea, but definitely be checking to make sure you're doing it right. Example 3, y equals x plus 2. So m is what's in front of x, but we don't have anything in front of x. What number should we have in front of x since there's not one there? The answer to that is 1. If you were thinking 0, I mean, that's a good guess, but if it was a 0x, we wouldn't have x there at all. So this is going to be 1x, and that means that m is 1, and then b is coming from the plus 2, so our y-intercept is 2. So I'm going to put a dot at 2 on the y-axis, and then I'm going to look back at my slope. Since it's 1, I want to make it into a fraction, so 1 over 1. So every time I go up 1, I want to go right 1 as well. So up 1, right 1, up 1, right 1. Again, I've been making a ton of points, but you don't have to make a ton of points. I will also say though, as far as like grading this goes, like it is easiest for me to grade this correctly if I can actually tell where your points are. So if you're like, oh, I'm going to be super cool and not actually put points and just have my line, that actually could make it more difficult to graph. You want to do at least 2 points so that I can tell, okay, did you put the y-intercept in the right spot and did you count the slope correctly and understand which way it was. Typically what happens, the easy mistakes to make are to just do your slope backwards from what it is, either switching up rise and run completely or accidentally going negative when you should be positive or positive when you should be negative. Those are kind of the two things to watch out for. If you're getting a line that's just going the exact opposite way, for instance, that means that you're thinking of the slope the wrong way, because we want to go up 1 and right 1, and you've gone down 1 and right 1 if it goes the opposite way. And then for this one, your rise and run are the same, but on a different problem, we could have our rise and run switched up on accident so that we're rising the bottom amount and running the top amount, which that's not going to give us the right line either. Moving on. So now we've got a negative slope. So here's the deal with negatives for negative slope. I'll write M and B down and then talk about it. So if our slope is negative 2/3, we have to understand that having a negative for a fraction means either the top is negative or the bottom is negative. It does not mean that they're both negative, because if both of them were negative, the negatives would have canceled out and made a positive. So I like to always put it with the top number, so I would think down to right 3, but you're welcome to think of it either way. So the second way of thinking of this would be to go up to left 3. And those are actually going to give us the same exact line. It's just the direction we're going from our y-intercept that would be slightly different. We're going to begin with 5. Then I'm going to go down to right 3. 1, 2, 1, 2, 3. Over here. Or if we do it with the negative on bottom, that'd be up to left 3. I really like to do at least 1 point each direction. So, but you can probably, if you look closely, you can probably tell that once I get past the points I've drawn, it is a little less likely. Like, I did a decent job putting it through the right point there. Actually, I did a pretty good job. But it's harder once you've stopped drawing points to actually get it to go through where those points should. That's why I focus when grading, I focus on that part in the middle where you've actually got the points. Okay, that's how we handle a negative. If we remember from the lesson on slope that a negative slope goes down to the right, a positive slope goes up to the right, we also can check ourselves. If after we've drawn this, it's going down and to the right, but it's not a negative slope, then you know you've done something wrong. Since it is a negative slope, it's going down to the right, that's a good sign. So, let's look at the next one. Example 5. Okay, we're missing something here. We don't have a b, right? There's not anything being added or subtracted here. So what would we do? How could we have plus something whenever in reality we have plus nothing? Well, wait, there's a number that represents nothing, which is 0. So this can seem a little tricky. Earlier when we just had x, we said the number in front of that was 1, right? If I just have x, that's 1x. But whenever we don't have something out to the side added or subtracted here, it's not that we put plus 1, because if it was supposed to be plus 1, they would have put plus 1. We just put plus 0 as kind of a placeholder so that we know, okay, it's saying the y-intercept is 0. That's what it's saying. And then our slope here is -7, which we're going to turn into a fraction, so -7 over 1. And again, the negative could be with the 7 or the 1, but not both. So either I want to draw down 7 and right 1, or I want to draw up 7 and left 1. So I'm going to start at 0, 0, and then I'm going to go down 7 and right 1. This one's going to be really, really frustrating to draw for me. Maybe not for you, but I don't like the really up and down steep ones. Okay, that wasn't too bad. We do put arrows on the end of our graph, or you'll sometimes see people just make their line go all the way to the end of the coordinate plane, which would denote the same thing. Like, we want to put arrows on the end to show that we understand lines go on forever. And then we also, sometimes people will put the arrow like right where their dots are, their end dots, and that actually kind of makes it hard to see where your dots are, so I don't recommend it. Also, I'm not a fan of like when you draw just a super little line. Like, it's a line. It's supposed to be a bit longer than that. So those would be a couple of the points that I would say, hey, draw your line fairly long. Doesn't have to be ridiculous, but draw it fairly long. Put arrows on either side. Make your line go past the points that you've found, and I think that's some good strategy there. All right, example 6. So we want to do 3x plus 9, and something special is going to happen here. You're welcome to pause and see if you can figure it out, but there is something at a different level of trickiness that's happening here. So m is 3, and b is 9. We will turn 3 into 3 over 1. Now, our y-intercept is at 9. We're supposed to go up 3 and right 1. Oh no, I'm out of room. Now, technically, I could just, make this graph bigger. But I'd say that teachers are not a super huge fan of that, because you just made the graph bigger, but look at all of the other room that's on this graph, right? What about going down and then a direction? Couldn't we do that instead? So kind of the point of this problem is to say, hey, if you're going to put a point off the graph, instead go the other direction. So instead of going up 3 and right 1, remember that we can think of this as negative 3 over negative 1, which is down 3 and left 1. So 1, 2, 3, 1. Because we got all this room. It's like when your toddler sits right next to you on the couch when there's the whole rest of the couch available for sitting. You know what I mean? It's just, why are you right next to me? There's all this room. Graph your line the other direction, toddler. That's silly. Never mind. Alright, so this is graphing lines, right? Pretty awesome. And I want to show you something else before we end, which is a really cool thing that I've got on my website. Okay, so check this out. On my website, link in the description, I've got what I think is pretty cool graphing lines practice. These equations are in slope-intercept form. Click the box to begin. So click new problem. We've got a key up here. Our answer that we draw is going to be in blue. The correct answer will be in red. And we're going to click 2 points on here, and then we can click show answer to compare. So for instance, I've got y equals negative x minus 1. So that's a y-intercept of negative 1. I'm going to come down and click here, and it is going to try to make your point be at grid lines. So keep that in mind, that if you're trying to click on a fractional part, it's going to force it to be on grid lines. Then I'm going to do my slope. So negative x would be like negative 1. So I'm going to go negative 1 over positive 1, so down 1, right 1. I'm going to put my next point here. When I click the second point, it draws a line. So let's see if we're right. So our graph is in blue. The answer is going to show up in red. Ta-da! They overlapped, right? Let's do one where I do it wrong on purpose so you can see. So let's see. Let's pretend like I didn't notice the negative for the negative 4. So I put my y-intercept here at positive 4, go up 1, right 1. There's my line. And I can click show answer, and I can see, okay, I got it wrong. And hopefully I can look at this and be like, oh, I got the slope right, but I got the y-intercept wrong. And then look at the equation and go, oh, I see. It's because I just didn't realize that negative was there. Then we can click new problem. I have this zoomed in a little bit, so if that's looking funny, I feel like it's looking a little funny. I don't know. Okay, let's do this one, y equals 2x minus 4. So I put a dot at negative 4. What if I accidentally get my slope wrong? So what if instead of going up 2 and right 1, what if I accidentally do it backwards? So this is another wrong answer. If I click show answer, I can see, okay, I got my y-intercept right, but for some reason my slope is wrong. And the idea would be to look at this and go, oh, okay, I should have gone up 2 over 1. I did backwards of that. So it's really important with math, and probably with everything, but what I know best is math as far as learning goes, So it's really important with math and with new concepts like this to be able to practice and know immediately if you're doing it right or wrong. Because what we want to do is we don't just want to memorize this, although that is one way of doing it. We want to have this so well understood that it's like it becomes a part of our like internal brain workings. So you're going to be graphing lines for the rest of the time that you're taking math classes. You never stop graphing lines after this point. They show up in geometry, algebra 2, pre-calculus, calculus. So the sooner we get the hang of this and the sooner we can go, okay, I get why this works, the better. So let me actually give you a little bit of the why this works the way it does. So we have the y-intercept, which is a starting value. We have the slope, which is a rate of change. So anytime we have an equation like this, we could come up with a situation that explains this. So for instance, we've got y equals 2x minus 4. Perhaps we are in debt to our parents $4. So that would give us a y-intercept of minus 4. That's our starting amount of money. But we plan to pay our parents back $2 per week. So we would be able to, let me get rid of my answer and just look at the right answer. So we'd be able to either use the equation or look at the graph. This is kind of an oversimplified situation, right? But we could look at this and say, okay, I'm starting off in debt 4, but how many times am I going to have to go before I get out of debt? I'd only have to do 2 slopes, right? Two weeks of change get me to 0. And so there's so many things in the real world that are linear relationships like this, where you either start with nothing, so it'd have a y-intercept of 0, or you start with a positive or negative amount. An example for this that used to work super well was cell phones. It still kind of works, but back in the good old days, that were not as good as far as cell phones go. Back in the day, you would pay some amount per month, and then you might pay, you still do this, it's different. You'd get so many minutes of talking, and then if you went over, they charged you per minute. That's a linear relationship. You have a base amount you're paying, and then you're adding for each minute. You do the same thing with text messages. You could get 500 text messages for $5 a month or something like that. So you'd automatically be paying $5 a month, and then every text you went over 500, you'd have to pay like 10 cents per text. It was super annoying. Now, instead, we do this with data, right? You pay a certain amount per month for your cell phone plan. If you have a smartphone, then they add on to that your data plan. So anything that's kind of like that, like there's so many services that are like that, that have a base amount that you pay, but then you also have a rate that you pay. So linear relationships are out there everywhere. And it may not be that we're, sitting at home in our 30s, drawing graphs of lines, but the understanding behind it is hopefully going to kind of permeate your mind so that you understand whenever you're looking at those situations, kind of the relationship that's happening, and it'll help you also to like compare things. So maybe one company charges more at the beginning but less over time, and the other one charges less at the beginning but more over time. Figuring out when those situations are worth it or not can be super helpful. That was kind of a lot of information that I may have lost you on, and that's fine. But please check out my website and this really cool way that you can do extra practice, because I think it's really awesome. Hey, thanks for watching. It really, really, really is awesome that you watched this video and that you made it all the way to the end. Good job to you. I would appreciate a subscribe, a like, a comment if you're interested, and I'll see you in the next video. Thanks.